Welcome back. We're going to be talking about abstraction now. When you hear the term abstract or abstraction, what do you think of? I think of Picasso or Salvador Dali, these abstract artists with their really interesting paintings. When you're looking at those, what do you see? I see sometimes, many different things. And that's the thing about abstract art. It is the idea of giving an abstract view of a reality, not a reproduction perfectly of reality, but enough that you can tell what the artist was trying to do. So, with abstract design, it is going to be about giving basically the hint of the reality that the artist or the subject the artist was painting, but not all the information. It is not an impressionistic piece or a photorealistic piece. It is meant to give this kind of abstract connection. There's another term that abstract is used in, and that is with scientific journals. In scientific journals, abstracts are a short document that's usually at the very top of a scientific paper that has all of the content of the scientific paper in it, and making sure that it's not just a summary, but more of a way of understanding everything that is important to know in this document. It is a simplified version. So thinking about both of these, abstract in art and abstract in, say, a scientific journal, you can start maybe to see that abstract is about giving a little bit of a knowledge about something, but not the entire knowledge, not the entire reality of maybe the 20-page scientific journal or the person that maybe Picasso was trying to paint. It is giving you an impression of that person, or just a understanding of the top layer of that. In computer science, there's a very similar idea, and abstraction in computer science we can kind of demonstrate a little bit with an alarm clock. Abstraction in computer science is meant to allow coders and programmers to be able to focus on more about how things are done, or how things are going to work for them, than actually how the device or the object does it. So, for example, let's take this alarm clock. This alarm clock, you might have one at home. You probably hopefully can set your alarm clock and make sure you wake up on time. Maybe not hit that snooze button too many times. So you can use this, but do you really understand how it works? Do you really understand how this display makes the screen work? How it displays the numbers? How these buttons actually make things happen? Probably not. And even if you do have kind of an understanding of the base electronics inside of it, you probably don't have a full understanding of how this specific alarm clock has been built. This is because a lot of times when we use things, we use them from what is called a logical perspective. A perspective in which we are using them but not knowing how they are actually accomplishing what we want. We know what the output should be, and we know what the input should be. But there's this big open area in between where the device or object is doing something, and we have no idea how it's doing it. And this is a core concept of abstraction. because the cool thing is we can use a fairly complex object with some very simple interactions and solve some big problems like waking up on time. You don't want to miss that class. You don't want to miss that important event. You got to wake up on time. So there are many reasons why abstraction is an important concept in computer science, and we're going to be pulling that apart today with this module. We're going to be going through a few different key concepts within abstraction. So check out the next video activity, and we're going to get started.